Hey friends, let's get through these FRQs and see if we can kind of wrap up the video on the reviewing. All right, this does allow your calculator. That does not mean you're going to need your calculator on everything, so kind of keep that in mind as you go through. Let f be the piecewise defined function consisting of 3 linear segments shown in the figure above, and then it gives you the function itself. Great. Find the value of f of 2. Keep in mind all that means is y when x equals 2. So I can actually see that right here, and f of 2 is going to be 2. So you're just looking on the graph. Here it says h is defined by g of f of x. These two are just different notation for the same thing. So to find the value of h of 2, I'm going to be finding the value of g of f of 2. Well, from up above, I know that f of 2 also happens to be 2. So I'm looking for g of 2. So they defined function g here, and I'm going to go ahead and plug 2 in to that equation. And I'm showing my steps because it's an FRQ. And then be really careful when you go to do that on your calculator. You know, take it step by step so that you end up where you want to be. And then it says find the value as a decimal approximation. So my answer is 14.4. Don't leave it as a fraction if it says to put your answer as a decimal. And don't leave it as a decimal if it says to write it as a fraction. Okay, we're finding the zeros as decimal approximations or indicate that there are no such values. Keep in mind that in order to find zeros, we're looking at the top or the numerator and thinking, what does that makes that equal 0? Because you can't have a 0 on the bottom or it's undefined. So we're going to go ahead and take that top function and try to factor it down to determine what the values would be. You can take out a negative 2x as a greatest common factor on this. You'll have x squared plus 3x and then minus 28. And then that factors, you need 28 in a way that subtracts to be 3, and you need the 3 to be positive. So in that scenario, my zeros are going to be the things that make each factor 0, and so they will be 0, positive 4, and negative 7. So those are the places that that function would have zeros. Now, we are determining end behavior. So look for those key words to figure out, like, what am I doing? As x decreases without bound. So that is telling you that x is approaching negative infinity. That is asking about the left end. Now, if you look at the leading term here and the leading term here from up in G, that would reduce to negative 2x squared. Your top is greater than the bottom by more than 1. So there's not a horizontal asymptote and there's not a slant asymptote. But we've learned that since this leading coefficient is negative, the right end will go down. Since this degree is even, the left will do the same. And so both ends will be going down. So it says express your answer using mathematical notation of a limit. So you absolutely have to write your answer as the limit as x goes to negative infinity of function g of x, because that's what we're talking about. And to say that it's going down, you would use negative infinity. So this is the way you have to write your answer to get full credit on that part of the FRQ. So on that part, I did not need a calculator for anything. So don't feel like going into it. If there is a calculator, you have to use it. All right, you can read the paragraph. In a large town, a local cable company experienced a service outage that prevented residents of the town from being able to watch their local football team play on television. As the local cable company began receiving phone calls to report the outage, residents were placed on hold while operators attempted to respond to the customer calls. The number of calls on hold is given in the table above. That's your Y, based on selected time in minutes. Okay. It is straight up telling you right here, the number of customers on hold T minutes after the service outage can be modeled by the function C. This is a quadratic model. You've got an x squared, it's going to be quadratic, and that means I need to use quadratic regression to do this problem. So I'm going to put these into L1 and L2. So I'm going to go to stat, and then I'm going to go to edit, enter in my data. Then I'm going to go back to stat, hit calculate, go down and choose quadratic regression. And it is going to identify the values of A, B, and C for me. A is negative, is negative 0.317. B is 7.117, and C is negative 7.5. So that's going to build an equation. I should probably left more room. That's going to be, I'll just write it here. C of t equals, I'm just writing this down as a function, negative 0.317x squared plus 7.117x minus 7.5. That is our quadratic function that represents the number of people on hold after a certain amount of time. But that answer does not belong here because this question, the second part in B, says use the given data to find the average rate of change. That is truly slope from t equals 3 to t equals 10. So I'm literally doing y2 minus y1. So I look up in the table, I get my y value from that and my y value from that. So my average rate of change, which you always have to just think of as slope, is y2 minus y1 over x2 minus x1. So I end up with 21 over 7, which is 3. And it says show the computations that lead to your answer, which I did. And that is going to be 3 customers per minute. Because if it's a real life application and you're doing an FRQ, I always highly recommend that you would go ahead and give them the units surrounding the answer that you got. Then it says use the average rate of change found in the previous problem to estimate the number of customers on hold at t equals 6 minutes. This is a little bit tricky, but what they're saying is you want to use that previous information to make an estimation. You need a line that you can follow that would have the same rate of change because lines have a constant rate of change. I'm going to go ahead and use this format for a line. And I'm going to use one of the points from up above. It doesn't really matter which, but I'm going to choose that. And then I'm going to choose my slope that we just got as our average rate of change as an estimate of 3. So I would have y minus 11 equals 3, which was my estimated rate of change, and then x minus 3. But I'm looking at 6 minutes, and 6, minutes is the x. So I'm going to have y minus 11 equals 3, and then 6 minus 3 will go in here. And so to solve for y, I'm just going to have 3 times 3 and then add that 11 over. So I'm going to end up with, and it says use the average rate of change to estimate the number of customers. So I would say 20 customers. So approximately 20 customers should be on hold after 6 minutes. All right, next part, consider the average rate of change from 10 to K in between 15. So now they're talking about something here. Our average rate of change from here to here was a positive 3. It's asking you to look at the second half of the data. Are these average rates of change less than or greater than the average rate of change from 3 to 10, which keep in mind was 3? Explain your answer. If you look at this data, you can see that there is an increase here and then a decrease here because this is quadratic. So it's going to go up and then it's going to come back down. So the rate of change here is going to be going up and then here it's going to be coming down. Meaning when I go to answer this question, I'm going to say C of t is quadratic. And when you have a quadratic, you're going to have an increase and then a decrease, keeping in mind that it also has a negative coefficient out in front. Like here's my answer right here. So this is going to be an upside down parabola. So we can tell by the data and we can tell by the model that it's going to be kind of going up and then coming back down. So C of t is a quadratic with a negative leading coefficient. So it will increase, then decrease. That has to happen because of the data and that we have in the table and also the equation that we got. So the average rate of change from 10 to wherever that K value is to 15 would be less than the 3 because it is decreasing at that point. You can see from the data that you have gotten past the max and are now decreasing. Okay, and then the very last thing in the FRQs, the local cable company wanted to use the model to make predictions about the number of customers on hold beyond 15 minutes. The Model C is an approximate model of a predicted number of customers is non-negative, meaning that it cannot be less than 0, but it can be 0. Based on this information, what is the largest integer value of t for which the model is an appropriate model? What they are telling you is that you're going to have a graph that goes up and comes back down, and you are only using that top part because down here doesn't make any sense. Now you have negative number of customers. So you are looking for the number or the time, because it says what is the largest value of t before that y value goes negative. So you're looking for where does c of t stay above 0. So what I did was I did a graph. I put the y1, I put in my function, I'll just call it the quadratic regression, and I put that in there when I was doing the calculation. Remember, you saved it as y1. So you can kind of ding around with the window, keeping in mind that this is 0, and you're kind of guessing. I think I went to 30 or 35, but on the on your y values, you can look up here and see that kind of the biggest y value is a 32. So I think for my y's, I went up to 35-ish. And then what I'm going to do is find the value of that number. So I went to second, trace, that's where I find max, min, and it's also where I find 0. And so I've used my second trace 0 steps, and when I did, I found out that 21.36 was where it hit 0. So 21 minutes would be the maximum number of whole minutes for which this is an appropriate, because it says largest integer, so you can't use a decimal. So you want to pay attention to all those words as you go. Hardest part is just figuring out, like, what are they asking me to do and how could I use my calculator to help me with that? So hopefully this helps you get through the FRQs. You got to be pretty comfortable with your calculator, and you got to be pretty comfortable with what the words are telling you to do. So think about that before you start doing anything. Good luck, guys.